Welcome dear friends. This is the simplest and easiest way of teaching learning process in our most popular YouTube channel Physics Make It Simple by Dr. Rajendra from Padmasri VK Patil Junior College, Pravara Nagar, Loni. As long as the 12th science oscillation is concerned, this is the lecture number 4, and in this lecture we will have to discuss three physical quantities, that is amplitude of oscillation, then period of oscillation and frequency of oscillation. So let us proceed the first definition, amplitude of oscillation. I will write it on the board. Amplitude of oscillation. Amplitude of oscillation. Amplitude. Amplitude of oscillation or amplitude of SHM. Amplitude of oscillation. So what is the definition of amplitude of SHM? Maximum displacement from its mean position. Particle performing SHM, maximum displacement of the particle from its mean position, we call it as amplitude of oscillation or amplitude of SHM. Let us see here. Suppose this is a simple pendulum and pendulum is at mean position. This is a mean position. Then maximum displacement from the mean position. We know the displacement is always measured from the mean position, from like this. This is the maximum displacement. This maximum displacement of the particle from its mean position, we call it as amplitude of oscillation. Amplitude may be plus A or minus A, like this. Here is also the maximum displacement from the mean position. Here is the mean position, here is the maximum displacement, and distance between two extreme position, we call it as path of SHM. So this is a path from this side to this side. This is a complete path of SHM. Along this path, the particle is oscillating, the body is oscillating. From this, we can say that path of SHM is the double the amplitude of SHM. Isn't it? Is it clear to you? Path of SHM is double the amplitude of SHM, because the amplitude of SHM is from mean position to this, and path is from this to this. This is a path. So we can say that the path of SHM is double the amplitude of SHM. Come to our original point, we will have to learn the definition of amplitude of oscillation, and definition we will write on the board. The definition is like this. What is the definition? What is the definition? Particle performing SHM, particle performing SHM, comma, maximum displacement of the particle from its mean position, is called as amplitude of oscillation. Amplitude of oscillation. Amplitude of oscillation. And amplitude is denoted by what? Amplitude is denoted by either plus A or minus A. Plus or minus capital A is amplitude of oscillation or amplitude of SHM. The second definition that we want to discuss is period of SHM. Period of SHM. So what is period of SHM? I will write on the board period of SHM. Period period, period of oscillation or period of SHM, period of SHM denoted by capital T. What is period of SHM? We will write the definition like this: particle performing SHM. Particle performing SHM, time required to complete one oscillation. So what is one oscillation? See here, one oscillation. We can measure oscillation from any side. Suppose we are giving oscillation like this: 1, 2, 3, 4, 5, 6, 7, 8, like this. Or oscillation may be measured like this: 1, 2, 3, 4, 5. By taking extreme position we can measure oscillation, or by taking mean position also we can measure oscillation. So time required to complete every one oscillation we call it as period of SHM or period of oscillation. So I will write the definition on the board. What is the definition? Time, at first we will write like this: particle performing SHM, time required to complete one oscillation or vibration. One oscillation or vibration is called period of SHM, period of oscillation or SHM. So we know the formula of period, capital T is equal to 2 pi upon omega. Such a formula we have already learned in rotational dynamics, and while learning the differential equation of linear SHM we also learn omega square is equal to k by m. I will write on the board: omega square is equal to k by m. Therefore omega we get is square root of k by m, where k is a force constant and m is a mass of a particle, mass of a body which is oscillating to and fro. By putting this value here we will get what? Capital T is equal to 2 pi upon, I will write like this: capital T is equal to like this: capital T is equal to 2 pi upon omega. What is omega? Which is equal to k by m. Then this may be written as like this: capital T is equal to 2 pi square root of m upon k. This is one of the important formula of period. How the another formula is derived? Then we will write like this. We know what? F is equal to minus kx. Numerically we will write F is equal to kx by taking magnitude only. F is equal to, we know F is equal to minus kx, but numerically we can write F is equal to kx, where k is what? Where k is equal to F upon x. By putting the value of k here we will get what? T is equal to 2 pi square root of what? M upon, what is k? K is what? F upon x. But we know according to Newton's second law, F is equal to ma, where a is acceleration. By putting that value here, we will get what? T is equal to 2 pi square root of m is as it is. What is f? F is equal to ma upon x. Then we get what? T is equal to 2 pi square root of m into x upon ma. That m get cancelled and you will get T is equal to like this. T is equal to what we get? T is equal to 2 pi square root of what? X upon a, like this. This may be written as, without changing value, 2 pi upon square root of a by x, like this. This square root of x upon a, take it on denominator, we can write square root of a upon x. And what is this a upon x? This is acceleration per unit displacement. I will repeat again, acceleration per unit displacement. So the formula will become like this: T is equal to 2 pi upon square root of acceleration per unit displacement. Acceleration per unit displacement, like this. Acceleration per unit displacement. And this is the another formula that we get, that is capital T is equal to 2 pi square root of 2 pi upon square root of acceleration per unit displacement. This is second formula, and that first formula we have already get. That formula is T is equal to 2 pi square root of m upon k, where k is called as force constant. So this is all about period. So take a screenshot, take a screenshot, take a screenshot. Then we have to learn, we have to discuss frequency of SHM. Okay, frequency of SHM. Frequency of SHM, frequency of oscillation, frequency of oscillation. I will write here frequency of oscillation, frequency of oscillation. Frequency is denoted by F. The first definition is very common. Frequency of SHM is a reciprocal of period of SHM. So we can write here particle performing SHM, like this. Particle performing SHM, particle performing SHM, frequency of oscillation, frequency of oscillation is a reciprocal of what? Period of SHM, period of SHM. Or best way we can say that F is equal to 1 upon capital T. This is the formula of frequency. Or best way, another definition we write is like this. See the another definition. I will clean the board at first and then we'll see what is the next definition. What is the next definition? The next definition we will prepare like this. number of oscillations, number of vibrations performed in 1 second, that is frequency. I will write here. Particle performing SHM, particle performing SHM, number of oscillations performed in 1 second, performed in 1 second is known as frequency of oscillation. We know capital T is equal to 2 pi upon omega, that we have written here. Capital T is equal to 2 pi upon omega, or omega square is equal to k by m. Therefore, omega is equal to square root of k by m. So, T is equal to what we get? 2 pi upon square root of k by m. That we have already derived this formula. So, take a reciprocal of this, we get what? F is equal to 1 upon T is equal to reciprocal of 2 pi, 1 upon 2 pi, and reciprocal of 1 upon root of k by m. Reciprocal we got is square root of m upon k. So, this is the formula of frequency. F is equal to 1 upon T reciprocal of period, and period we got is 2 pi upon square root of k by m, So, we will get is what? Okay. See here. I have done one mistake, I think. We get what here? T is equal to 2 pi, and by taking this like this, we get what? Root of m upon k. So, we get what here? F is equal to 1 upon 2 pi is equal to reciprocal of 2 pi is 1 upon 2 pi, and reciprocal of m upon k will get is what? Will get is k by m. Reciprocal of root of 1 upon k, we get root of k upon m, like this. This is the formula of frequency. Or we can write like this. We also know the formula of period. T is equal to 2 pi upon square root of acceleration per unit displacement. Take a reciprocal of this, you get what? F is equal to reciprocal of 2 pi is 1 upon 2 pi, and 1 upon acceleration per unit displacement, its reciprocal is square root of acceleration per unit displacement. So, these are the two formulae of frequency. F is equal to 1 upon T is equal to 1 upon 2 pi square root of k by m, and F is equal to 1 upon 2 pi acceleration per square root of acceleration per unit displacement. In this way, today we have learned 3 definitions of amplitude, period, and frequency. Then after learning this, we will meet again by taking the next article in next time. Till goodbye.